Okay, here's a problem that gives us a thermochemical equation. It's balanced. It's got the thermochemical information included. It says that the enthalpy of the reaction is negative 802 kilojoules per mole. So it's an exothermic reaction. Energy is released in this case. Remember, the word released implies the sign. And so we don't include the sign in the per expression. So in this case, I'm given 432 kilojoules, and it's asking me to calculate how many grams of methane must be burned to release that much energy. So again, it has the negative sign in the delta H, but I don't include that in my calculation because I'm going to tell the reader the energy was released. That means the negative sign is implied. Okay, I could say that I'm given this 802 kilojoules per mole released as well, but it's part of the chemical equation and it's also a per expression. So I'm actually just going to leave it out of my planning altogether. Now, when I say I'm going to leave it out of my planning, I'm not going to write it down as something that I'm given. I'm just going to leave it with the chemical equation. Okay, what am I asked for? I'm asked for grams of CH4. So that means the plan is to go from kilojoules to grams of CH4. Now, remember that the enthalpy of the reaction, the thermochemical information, is a per mole per expression that tells you how much energy is released or absorbed in a chemical reaction based on the stoichiometry of that reaction. So in this case, it's 802 kilojoules released per 1 mole of CH4, per 2 mole of O2, per 1 mole of CO2, and per 2 moles of water. So then that means the step-by-step plan is to go from kilojoules to mole of CH4, and then mole of CH4 to grams of CH4. So let's put it together. 432 kilojoules, 802 kilojoules released per 1 mole of CH4, and then the molar mass of CH4 is 16.04 grams. And then putting that into my calculator, I get 8.64 grams of CH4 must be burned to release 432 kilojoules of energy. Okay, that's it.